All right, hello everyone, and welcome back from the break. Before the break, my colleague Aman showed you some of the direct modeling and surface modeling approaches that you can use in BricsCAD. In the next exercise, we will cover some of 3D constraints, as we already explored some of them in the first exercise. We will be looking more into how you can apply 3D constraints and also generate some parameters. This will be the third exercise. I will also go through the fourth exercise of the manual. The fourth exercise develops a bit more on the parameter side of things, linking parameters and constraints. It is fairly short, so we will do both of them at once. And similarly to before, we will also go back to a breakout room where you can then try these for yourselves. As it states in the guide, the exercise will use the communicator extension of BricsCAD. This is because we will showcase the importing process of a model. One of the advantages of having a direct modeling approach, as seen as in the previous exercises, is that imported geometry can behave and be treated exactly the same as in native files made in BricsCAD. However, if you do not have the communicator extension enabled, you can simply find the file folder 3D constraints. Here is the file that we will import. But if you do not have the communicator installed, you can simply open the step 1 file in the intermediate file folder. Then you will have the already imported model ready. But I will follow the exercise manual and I will start on the exercise now. And then, as mentioned, later you will have a chance to go through the exercise yourself. I will start just by opening a new drawing, simple mechanical millimeter template. From here, I'm going to, of course, now this is an empty file, so I will import the geometry that I showed you earlier. In the top left, I can click the BricsCAD symbol or BricsCAD symbol. Here you will see the import option. You can also use the import command if you wish. And here you can see the step file I wish to import. So I will just select open. And here it will import the geometry of the file. Now, like I mentioned, this is not made in BricsCAD, but it is still recognized as a 3D solid, which is what we have been modeling previously. So it will still behave exactly as if we made it in BricsCAD. So for example, to start with, I can select the model and I can change some of the properties of it. For example, the color. Previously we have changed it to green. You can also select the select color option here at the bottom of the properties panel. That way you can have a wider range of colors to choose from. You can also use a color code here if you wish. So I can use, for example, the color code 61. And you can see it will change accordingly. Also, if you are importing the model and it is imported as a block reference, this can be because of some of the settings that you have enabled in your software. If it is imported as a block reference, meaning if it is not a 3D solid as it is for me, you can simply select the block reference and use the explode command. This will turn it into a 3D solid. However, if it is already a 3D solid, please do not use that option. Now we will change some of the dimensions and some of the sizing of this part. We are going to apply some constraints, and to do this and make this process a bit easier, we will start by removing some of the fillets and more complicated shapes. We will just simplify it essentially. So to do this, I will select this radius. We will remove all the radiuses or radii from the model. To do this, you can either select each and every single one manually. Of course, this is a bit tedious, so you can select this radius here, which is the largest on the edges of the solid here. And through the command line or through the quad, you can hover over the select option. And here you will find this symbol, which will be called same or less radius fillets. By enabling this, it will select all the other radiuses or radii that are either equal to this radius or smaller. So now, very conveniently, all of these have been selected for me. I can simply select the delete key on my keyboard. And there we have already simplified all the radii. In a similar fashion, we will delete and remove some of the extruded features here, such as the cutouts. To select this, you can select the faces manually as well, or you can hover over one of them, and through the select option, you can see the depression option. So we can select this, and it will select the surrounding faces and the bottom face of this for us. Once again, I can select delete, and it will be simplified for us. And I can do the same for both of these parts. And delete. Now, one thing to also keep in mind is when you import geometry, sometimes the translation of the geometry can cause it to have unnecessarily complex shapes or surfaces. So for example, in this case, we can look at the cylindrical faces here. The cylinder is split into two faces. However, they share the same area and they share the same radius. So there is really no reason why they should be two faces. So to fix this, we have a command called dm simplify. So I will just type in dm simplify and hit enter. Then I can select what geometry and entities I want to apply it on. I want to do it for the entire model. So I will select the entire model in my command line. In the bottom right corner, you can see geometry was simplified and topology was simplified as well. And if I go back to these cylindrical faces, it is now one complete cylinder. It is no longer split into two. So it is a very valuable command to use when you are working with imported externally made files. Previously, you used a fixed command or fixed constraint, and you used an angle constraint. We also have distance constraints, which I will use now, which on the top of my screen here on the ribbon, you can see this symbol called distance. I will apply this to the faces here on this slab. By selecting those two faces, you can see it gives me the current distance between them. I can apply this and accept this value if I wish, or I can change the value already to something else, for example, from 19 to 15. By selecting that, you can see that the top face moved downwards a bit to accommodate for this change. In the mechanical browser panel, you can see now that I have a new folder called constraints, which is where all my new constraints will appear. So this distance one is a value of 15 millimeters and is now controlling the size and thickness of this solid or this slab. If I expand it, you can see the planar faces that it is placed between. So you can easily see which parts that it is applied to and which it will change. Also, if you want to see an easier representation of what the constraint actually does, you can simply right-click on the relevant constraint, and you can see the animate option. And if I select this, you will see the top face or the thickness of this changing and moving. So it will change the value of the constraint so that you can very easily see how exactly it's affecting the model without having to manually change the values of it. Following this, I will do the same on the rest of the thicknesses here. So this face to this face, for example. This is also 19. I can then again change it right now, or I can accept it. Now it is 19 here, and I can go into the mechanical browser and change it from here at a later stage also. So you can have the freedom to change that as you wish. Now we have 3 constraints with the same value, and they do the same thing essentially. So in this case, we want them all to stay connected so that these slabs will always have the same thickness. To do this, we can create a parameter that can control all of these values at once. To do this, you can select the root node in the mechanical browser and right-click it. Here you will see the Add New Parameter option. And here I have a new folder now with parameters. I can change the name of this by selecting it, going down to the bottom of the mechanical browser and giving it a name, for example, T for thickness. And then I can change the expression as well in the bottom left to 15. So now this parameter has the same value as the constraints. However, they are still separate. And to connect these with each other, I can select this constraint, go to the expression of the constraint, and change the expression to T. So T being the name of the parameter, meaning that this constraint will now take the value from that parameter. As you can see, the value now is T. If I change or animate the parameter T, you will see the bottom faces here change in distance. And then I can do the same for the others. I can select both of these at once by holding down Control and selecting them. Then I could give them both the value T at the same time. And now if I animate this, the thickness overall will change accordingly, as all these constraints will be controlled by the same value. So following this, we can also add an angle constraint between here if we want to control the angle between these faces. So like before, I can use the angle constraint, place it on this top face and this angled face here. It now has a value of 114.22, which is not very rounded. So I will just accept it for now. I will see it in the mechanical browser, and I will change the value from this to something a bit more rounded, such as 120. And there it will change. One thing to keep in mind when you change this is that we were playing with the design intent earlier. Currently, there is no design intent enabled. And you can see that these holes that are attached to this are no longer fully perpendicular to the face. It might be a bit difficult to see, but they are at a slight angle now since I changed the angle of the face, but the holes will stay in place. If you want to keep them perpendicular, you can use the design intent for this situation. So I just undid the previous steps. I also undid the angles. I will replace it. And if I go to the solid tab, find the design intent, I can switch on the perpendicular cylinders, meaning that now the cylinders should stay perpendicular to the face that they are attached to. And I can also turn on perpendicular planes. You saw earlier that the top part here also stayed in place when I changed the angle. So with these changes, it should now stay connected here. And the relationship between the geometries should stay intact. So I will change the value once more to 120 for the angle. And you can see the entire feature moved. The holes should now be perpendicular to the surface, which it looks like they are. Same for the top here. Actually, you can also see that the rest of the part here moved, while the hole here didn't. However, the hole is still perpendicular. So I will once again go back and undo the value of the constraint, To keep that in place, you can see they now share the same axis. So you can also turn on the coaxial surfaces design intent. If I change the value now, it should also be sticking with the rest, and it will still share the same thickness, or say share the same center. So it is now no longer out of the same center. Also, having coaxial surfaces enabled means that, like these parts, they will share the same center. These holes here from previously will also currently share the same center. So if I, for example, use the move command on this, I will just place this here, and I can see I'm only moving one of the holes, but you can see both of them will move together. This is the result of the design intent, then keeping them as having the same center. So that was the first exercise. It's fairly simple. Next up is a bit more, an exercise that delves a bit more into the parameters and such. It is also fairly straightforward, and the guide is fairly easy to follow, I would say. So I won't spend as much time explaining it. Here we have a rib feature. This already has some constraints placed on it. You can see there is a total length applied to it here. You can see there is a value that controls the thickness of the rib, distance between the ribs, and the distance from the rib to the front face here. However, none of them are working together currently. They are all separate. And we will then fix this and change this. First off, I will enable coincident planes so that all planes that are attached to each other will keep the relationship between them. And I will go ahead and create a new parameter. I will give this parameter the name of W. It will be a lot of numbers and a lot of different letters right now, but once you are doing this yourself, it will make more sense just following the guide. I will give this a value of 20. We can see we already have some constraints also with the value of 20. So like before, I can select all of them and give them the value of W, which is the constraint I created. Now this constraint or parameter will control the thickness of all the ribs all at once. Following this, we can change, you can see that the constraint controls the sizing of it. We can also create a new parameter and call it a D. So to do this, you can also use expressions or formulas to control the value of certain things. So for example, here I can give this D parameter a value of distance 1. So I will give it the parameter, the value of distance 1, the constraint, which is 300. So essentially 300 divided by 3. Now what this does is that it, like I said, divides the value of distance 1 into 3. This is valuable now when we want to change the distance between the ribs. So this value here in between each rib is a value of 100. So I can now give the distance here between them the value of the parameter D. And the distance between the ribs are now controlled by this formula. Also, the distance from the front face to the rib should also be controlled by a parameter, I would say. So just following the guide, I will give distance 7 an expression, which will be the following parentheses D minus W, end parentheses, and divide that by 2. So we will take the distance from this parameter, which is dividing this constraint, minus the width of each rib, and divide this by 2, which will then give us the value from the front face to the back face. It might seem a bit complicated, but essentially it is just basic maths. and it is fairly easy to fill in, and you can then see in the end how everything behaves together. Now, if I change distance to 1, you can see I'm changing the entire distance of the part. You can see the parameter that we created for D, meaning the distance between the ribs, will change accordingly as it is using a formula that depends on the total length. So as the total length changes, the length between the ribs will also change. And since we are doing the same thing with the distance 7 from the front face to the first rib, it will also depend on these values and will adjust accordingly, making sure that the entire distancing between everything is even. So, like I mentioned, the first exercise is a bit on how to place certain constraints. The second one is a bit more how to connect constraints and parameters. Please follow the guides and you will get there, no problem, I would say. But now we will move to the breakout sessions where you can try it for yourself and you will get to ask us questions as well.
Download BricsCAD today and start your free 30-day trial.